Now we already know the principle of VRRP protocol, right? And we know that how to create the VRRP group. And if you want to know what's the detailed command and how to create the configuration and how to add the devices into the VRRP group, if you want to know it, please follow me together. Let's do it.
Hello guys, this video we will talk something about the VRRP lab guide. And first let's see the background. On a company's network, and layer 3 switch server serves as a gateway of the network. However, because the device often main function due to its long service duration, so as a result, internal net users has a very poor network experience. The company decided to purchase another layer 3 switch to improve network reliability. Like the topology here, switch 1 and switch 2 will become these two layer 3 switches. And we want to use a protocol we call is VRRP, Virtual Router Redundancy Protocol, to meet the requirement and can provide multiple gateway and as a backup. And about this lab purpose, we hope we can understand and master principle of VRRP technologies, and also can master the application scenarios and configuration of VRRPs. And this is a topology. And about this lab, there are two requirements. The first one, the port connect with PC, connect with PC1 belongs to VLAN 10, and its IP address about this PC is 192.160.1.1/24, and the gateway address is 192.168.1.254. And the IP address of switch SVI interface 10 of switch 1 and 2, the address is 192.168.1.255, and another one is 253. And we hope that switch 1 can be the master gateway. And if the switch 1 is faulty, switch 2 can be a new gateway. So this is a requirement. If we want to meet the requirement, there are 4 configuration ideals. Complete the basic configuration such as the VLAN and IP address. Basic configuration 1, right? And we also have to configure the interconnected ports of 3 switches to work in trunk mode and configure VLANs on them. And we also have to configure STP protocols, right? Because there, if you only have 3 switches, there is a loop. We have to run in STP to avoid loop. And switch 1 can be the root bridge. Switch 2 is a backup root bridge. And the next step, the last one, we have to add the VRRP and set the priority of switch 1 to become 120. So switch 1 can be the master because it has higher priority. So there are 4 steps. And about the detailed process, because we have 4 configuration ideas, and here are 4 steps how to configure one by one. And about the lab guide, we directly skip the first, second, and third operation because we already know the basic how to configure the IP, configure the VLAN on the previous practice, right? And also includes the STP. So about the detailed video, I still will configure one by one. But if you think that you master everything, maybe you can skip this video and directly to see the last step, how to configure the VRRP. Now first, let's give the basic configuration of IP address at first. The first one is the PC1. PC1 IP address in your real network, maybe in your real network, you will use a DHCP to let PC1 get an IP address. It doesn't matter to do manually assign IP address again. But in this topology, we still use a manually way to give a static IP address. And the command is IP 192.168.1.1, and the mask is 255.255.255.0, and the gateway is 192.168.1.254. Okay, so now you configure the basic IP address for PC1 successfully, right? And about the switch 3, we only is an access interface, access switch. So we don't need to give any configuration of the IP address on switch 3. But switch 1 and switch 2, we have to give the IP address because we have to create the SVI interface. Before we add the IP address of switch 1 and switch 2, let's finish the layer 2 configuration at first, includes the VLAN, the STP, right? And here, about switch 3, we have to do some command. And enable, give the password, Ruijie123 dot. And config T, and change the host name to become switch 3. Okay, and you have to create VLAN 10. This is a VLAN. And another one is connect with PC. This interface should be access interface, right? So you can directly add the interface gigabit CL2. So this is a basic. And about the other two interface connect with switch 1 and switch 2, this should be the trunk interface. So you have to exit and enter the gigabit 01, enter. And you also can use the command range to give the multiple configuration between gigabit 1 and gigabit 0, right? Because the command is same, you change the mode to become trunk and allow the VLAN 10 pass through. Of course, if you configure one by one, it also can work. And you have to use the mode switch and to change the mode to become trunk. And about your trunk, by default, your only suggestion in your real network only allow your service of VLAN pass through. VLAN 10. It's okay about the gigabit 01, and also enter another interface. Switch mode to become trunk, and also your trunk interface should allow VLAN only 10. So if you now exist and show your VLAN, you will find VLAN 1 and VLAN 10. And now you only 3 interfaces can allow the VLAN 10 pass through. So this is a basic configuration of the switch 3. And the suggestion when you do the practice is step by step. Now you create VLAN 10 on switch 3, right? And you also can enter the VLAN 1, add the basic configuration of VLAN at first. Someone maybe say, I also want to do the STP protocol on switch 3 at the same time. It also can work, but suggestion, if you are not very familiar about most protocols, please do one protocol, finish everything, and then do the next step. Otherwise, it's a little difficult for you to do the troubleshooting if your network cannot work. If you are very familiar about everything, you can directly to give all the configuration on one device and finish everything and go to the next step. It's a little difficult if you have some fault. Config T, host name to become switch 1. Yes, and you also have to create VLAN 10 and Because now about switch 1, we only have 2 physical interface, and both of them should be trunk, right? You can directly enter the range gigabit 00 to 1. Multiple interface, and switch the mode to become trunk. And switch trunk allow only VLAN 10. Yes, so this is basic configuration here. And about the switch 2 also is same. Enable yes, and config T to change the host name to become switch 2. Then create VLAN 10 and exist enter range. Someone maybe say I don't use the exist directly to use command enter range gigabit. It also can work, but maybe your cable tab cannot be used in the incorrect page view. Switch mode to become trunk, and switch trunk allow VLAN only 10. It's working. So now this is a basic configuration of the VLAN. Another one is you have to create the STP, right? And about the STP, switch 3, you have to enable the STP at first. Spanner tree. Spanner tree and enter. Now you already enable. And place speak the mode to become mode. So it doesn't matter, like me, I already do lots of practice of STP, but I still will forget what's the detail command. It doesn't matter. Only enter the question and then the command will let you know what's the next configuration here. So this is a basic configuration of the S3. And another one about switch 1, you also have to enable at first. Spanner tree. And choose the mode to become STP. Spanner tree to choose the mode to become STP. Right? And now we hope that switch 1 can be the root bridge. So you can directly change the priority. Spanner tree. And directly to change the priority to become 0, right? This is highest priority of the spanner tree. And about the switch 2, this is a backup root bridge. And exist and the spanner tree, enable at first. And to choose the mode to become STP. And also you can change the priority to become like 4096. Okay, so now you will finish the basic configuration of the spanner tree. And you can use the command to check the result. What's the status of each interface? Show spanner tree. And you can directly enter. Or maybe this is detail. You can see some summary information here. You will find now the root priority is 0 and the root MAC address is same with this interface, with this switch MAC address. So now switch 1 is the root bridge, right? And all the interface will be the forwarding status. And about the switch 2, you also can show spanner tree summary. Here, you can find these two MAC addresses is different. And the priority here, this is a backup interface. So this is a basic configuration of the STP, and also you have to create the basic IP address of switch 1 and switch 2. You have to create the SVI interface VLAN 10, and the basic IP address is IP address 192.160.1.252, and the mask is 24. And also in switch 2, you have to create VLAN 10, and the IP address is 192.160.1.253.24. Okay, so now this is a basic configuration of the IP address. After you stop here, the first 3 steps you will already finish. And now this is a basic configuration of the VRRP, right? First, let's say the switch 1. About the switch 1, we hope that the switch 1 can be the master router on the VRP group. And you can change the priority because now the IP address value is smaller than switch 2. So first we have to create a VRP group. Group ID is 10, and give a virtual IP address is 192.160.1.254. This IP address must be same gateway address of the terminal. And another one, this IP address must be same segment with the physical interface. And the third one, if you configure the virtual IP address is same with the physical interface, this switch will be the IP address owner. And in the VRP group, we only have one IP address owner. Maybe we don't have. If we have, we only have one. If you have multiple devices to be IP address owners, that means your physical interface, there's some conflict, right? And this is a basic configuration here. You will find the data will become the backup at first, and now will become the master. Because now in the VRP group, we only have one device. This is switch 1. So this one will directly to become the master. And then you have to change the priority to let switch 1 become the master. Otherwise, when we add the VRP configuration on switch 2 will become the new master. So the configuration here is VRRP 10, and the priority to become 120. It's successful, right? And about switch 2, on the SVI interface to add the VRP 10, and the IP address is 192.168.1.254. Also, same limitation when we do the VRP virtual IP address on switch 1. There's some limitation about the physical interface and the virtual interface. And another one is the virtual IP you create in different physical devices must be same. Okay, enter. The data also will change from the initial and to the backup, and will never become the master, right? Because the switch 1 has higher priority. So this is a basic configuration of the VRP. It's very easy. If you will have some monitoring function in your network, it's a little complex because you have to add the check configuration here. But in this exam, it's very easy. And after you finish the configuration, you can check the result. Exist and show VRP brief. Enter, you will find that the group ID, what's the priority here, what's the timer, and what's the owner, what's the preemption master, what's the address, something like this, right? Okay, and about the switch 2, you also can see the result. Show VRRP brief. Okay, so this is the result, and the data is backup successfully. And about the PC1, now you can find if we finish paying the gateway 192.168.1.254, ping the result. First, we can ping successfully. And the second one, you can check the ARP table now. You will find about this IP address. The MAC address is a virtual MAC address because the first value are fixed 00005A0001, and A because we use the VRP group ID is 10, so this will become the A. Okay, so this is a basic configuration. And another one is physical interface. We also will record the MAC address of 1252. This is a physical MAC address, physical IP address of switch 1, and we get the MAC address here, right? And then when you check on switch 1, show interface VLAN 10, you will find the MAC address is this one, 5B02. This is the same MAC address on the ARP group on the PCs because now switch 1 is a master, will give the reply. And also you can use the command show VRRP interface VLAN 10. You won't find the virtual MAC address here, right? This is a basic configuration of the VRRP. Okay, so this is the basic configuration of the VRP here now. And about the switch 2, you also can find some virtual MAC address. And later we can test if our VRP configuration is successful now and we turn off one physical link. What's the result? For example, about switch 1, you can shut down all the physical link or maybe directed to stop these devices. We will have the same result. But if you use the stop way, maybe you can direct it to write the configuration here at first. Otherwise, if you stop here, maybe you will lost every configuration. You also can directly to shut down all the physical interface. You also can test the result. And after we finish to stop the physical devices of switch 1, we will find some warning. Now about switch 2, we will receive that the warning. Now this switch already from the backup to the master, and there's some other warning for the STP, right? And then we can check the result. Show IP, not show IP. Show VRRP brief. And you will find now switch 2 will become the master. And what's the master physical IP address? This is the IP address of the switch 2, and what's the group IP address? And later, if PC want to ping again to test the result and check the ARP table, you will find that the virtual MAC address and the virtual IP address also exist on our ARP table, and except this one, we will record another new ARP MAC address of the physical interface about the switch 2. And this physical address is the MAC address of the switch 2 SVI10. Show VRRP VLAN. You also can use the command show VRRP VLAN, show VRRP brief to test the result, right? And then you can check the interface VLAN 10, and you will find the physical MAC address is same with the ARP table on PC1, 58502. This one is same. And about the PC still can ping successfully. So that's all about the configuration of the VRRP. You can create multiple layer 3 or maybe router to become the VRP group member and select one to be the master and the rest of them to become the backup. And in the real network, maybe we will mix the VRP and the STP together because like this topology, if here you don't enable the STP, maybe there is a loop. So when you do the configuration, please keep the root bridge in STP is same with the master router in the VRP. That's all about this practice. Thank you.